Alright, so one of the other things we went over today in class, we've gone over this in previous periods as well, but let's touch on it again. What I've got here is a graph of a transformation. So we know that the parent function of a quadratic is equal to f of x equals x squared. So if we create that table really quick, you know that at negative 1 squared, negative 1 times negative 1 is just 1. When x is 0, 0 squared is 0. And let's see here, we've got when x is 1, 1 squared is just 1. So our parent function on this graph, if this is our x and this is our y, we're going to go from 0, 0 to 1, 1, and it's going to keep going obviously, but these are just the points that we calculated. And it starts at 0, 0. So first things first, let's figure out what our shifts were. And the shifts, if we recall, are our vertex. So if I've got f of x is equal to, we don't know a yet, so let's leave this blank, x minus, looks like we shifted over 3. So recall when the transformation is with the coordinate it's supposed to be, it does the opposite of what we would think. So like a negative 3 is going to move this to the right, because this is a horizontal transformation and it's with the x. A and k are on the wrong side of the equation in reality. So they're going to do what we would think, but that's only because they're actually on the wrong side. So with that being said, again, this is on the wrong side, so to move it up 10, we're going to make it a plus 10. If it were with the y where it's supposed to be, it'd be y minus 10, right? If we subtract 10 from both sides. So just remember the academics behind why we say on the outside it does what we think, the inside it does the opposite. It's just because the vertical transformations are actually on the wrong side of the equation. So that would bring us to the right 3 up 10. We now are at our vertex. If we're trying to find our y, or I'm sorry, our a, we need to look at the same distance traveled in our parent function horizontally. So if we travel over 1 in our parent function, we travel 1 up. In our new function, if I travel 1 over, it looks like I'm going, so from 3 to 4, we're going to go up 0.2, right? The difference between 10.2 and 10 is just 0.2. So 1 times 0.2 is equal to 0.2. So that would be our A. Right? Multiply by whatever it is to get to here. 1 times 0.2 is 0.2. Now, one of the things that we should remember is you're not always going to be given 1 over and 1 down. And that is important because a lot of you are thinking of this as just, oh, whatever that is, this is 0.2 and we're good to go. That is not actually academically what is happening. So let's try, what is that? From 3 to 10 is going to be 7 over. To go 7 over, we go from 10 to 20. That's going to be a move upward of 10. So to go in our new function, to go over, again, 3 to 10 is 7. So to go 7 over, we're going to go from 10 to 20. That is 10 up. In our original function, so in our parent function, to go 7 over, right, that would be our x. So 7 plugged in for x, x squared is 49. Okay, so we need to now find what value 49 times what is equal to 10. So if we want to do that on the side over here, 49 times some value, let's call it, I don't know, z. We don't really care. It can be any variable. Is equal to 10. So to solve for our z value, then we're going to divide both sides by 49. And we're going to get z is equal to 10 divided by 49 is going to be 0.204. So let's just round that to 0.2. Ah, that is 0.2, and so was it when we found 1 over and 1 up. So the point I'm trying to make here is remember that it's 49 times some value to equal this one. We're not always going to have it be so simple as 1 times something is itself. Or something times 1 is itself, rather. So keep that in mind. But either way, we took a look at this graph. We didn't even have a parent function to review against it, and using these 3 points, we were able to find our transformation. We could have just used these two, or we could have used this one and this one. Either way, we could have found it just fine. Now that we have our function, we're going to try and create a graph based off of this. So if we have this graph, x and y, a little bit higher, we know we need to go 3 to the right, right? It's the horizontal shift is with x, therefore is going to do the opposite of what we think. The y transformations are on the wrong side, so they're going to do what we think. So up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be right about there. That'll be our new starting point. Now where we used to go up 1 to go over 1, we're now going to go up 0.2. So for going 1 over, around here, if we look down, we're going to go up, if this is 1 here, we're going to go up a fraction of that, so we're going to go up to about here. The same thing over here, to go 1 over, we're going to go a fraction of the way up, so that'll be right there, right? We can't reach this point. This is 1 up, and we need to go 0.2 up. Then we can draw our quadratic through the points. Right, this is a vertical shrink. So if we now actually go to Desmos, we can actually compare this graph to our y equals x squared. And if I shifted this up to it, so you can really compare it, I mean, you can tell that it's shorter and fatter. So in this video we went from the function to the graph, and we went from the graph to the function.